to do this. They actually said 10 minutes to start with. It's growing a bit, but that's good because I've got lots to talk about. The question is not what to put in such old plant. This is what to leave out. I mean, the oceans are huge. They're 2/3 of the surface of the Earth. They're intimately connected with the climate system. But I thought I would talk about 3 things that affect the oceans and affect us. I'm going to talk about sea level and problem of rising sea levels and flooding. I'll talk a little bit about the overturning circulation, which is a little bit more esoteric, but it's what I'm actually working on at the moment, so you have to give me the opportunity to bore you a little bit about my favourite subjects. And then finally I'll talk a little bit about ocean acidification, which is the part of the climate change problem, though it isn't really a climate problem, the part of the CO2 problem that doesn't get talked about enough, I think, and it's the sort of the Cinderella part, and it's actually very simple. It's the one you can't, no climate skeptic can deny ocean acidification, and I'll come on to that in a minute. So, sea level. Sea level rise, it comes from a number of causes, and the first one is the land is sinking. Southern England is sinking at about 2 millimetres per year. And that's nothing to do, well, it is to do with the climate. It's nothing to do with the anthropogenic climate. It's nothing to do with us putting carbon dioxide into the ocean. That's to do with the fact that in the last ice age, we had huge amounts of ice over the northern hemisphere, and that compressed the rock and pushed it down. You've got several kilometres of ice sitting on top of the rock. And when you take that off, it takes time for that rock to come back to where it should be. So Scandinavia is rising, and the rest of the world is sinking. And okay, the last ice age was 10,000 years ago, but it's still happening today, and sea level has slowly been rising since the last ice age. And that's the purpose, that's the reason why that's happening. That's called global isostatic adjustment, or glacial isostatic adjustment, and it's about 1 millimetre a year on the annual global figures. So when I'll show you some pictures in a minute, and it'll say GIA included, and that's because they put this 1 millimetre a year on top of what we've measured, which is the fact that the land is just going up. Then there's the expansion of seawater. As you heat seawater, as the planet warms from rising CO2, that heat goes into the ocean, and as you heat things, they expand. And about half the increase we have, we believe, comes from the expansion of seawater. So as you warm the oceans, they expand, and we'll see later some effects of that. The third reason is the melting of glaciers, these continental glaciers, glaciers in the Alps, South America, the Himalayas, and they're putting quite a lot of water from ice into the ocean. And finally, the one that's a reasonable amount, but it's not huge. The one that's the other half, basically, is melting of polar ice sheets. So there are ice sheets in Greenland, and there are 2 ice sheets in Antarctica. They look like there's only one that's really 2. And they are melting. And we believe, we don't actually have very good figures on how much they're melting, but they're getting better, and that's where the other half is coming from. So you're melting ice sheets, and one of the worries is there might be a catastrophic melt of one of these ice sheets, and the ice sheet would actually slide off into the ocean. And if you melt Greenland, you get about 5 meters. If you do the West Antarctic ice sheet, I think it's about 10. The East Antarctic ice sheet, I think no one's that worried about. That's a lot more. Those are very unlikely to happen, but they are melting. We've got much better handle. If I'd been given this talk 5 years ago, I would have said we didn't really understand how ice sheets melt, and it was really scary stuff. I think now we do understand a lot more about how ice sheets melt. The prospect of a catastrophic collapse, I think, has gone away a little. Our understanding, our worry about that's gone away a bit. They mainly melt where they meet the ocean. It's mainly the warming of the ocean is melting the ice sheets. They are melting on the surface as well, but that's the other half. There is another component, a tiny component you have to include if you want to increase the budget, and that is land storage. Irrigation takes water and it spreads it over the world, and that is, I can't remember exactly how much, but it does actually enough to figure in the calculations. So what do we think's happened to sea level back to where we have reasonable records? These plots I'm going to show are all from some colleagues in Australia, CSIRO. This is looking at sea level from 1880, when the first tide gauges were installed, up to the present day here. And this blue line is what we estimate global sea level is from tide gauges. That's a very uncertain thing, and these are the uncertainty bands on there, because tide gauges are very irregularly scattered around the world. They're mainly in the northern hemisphere. A lot of them are in harbours. They're not in great places to measure. There's nothing in the South Pacific. So they were very uncertain what happened here, but it was increasing by about 1 millimetre per year. Now this red line at the end here is when we started getting satellite observations. And we measure sea level by having a satellite that has a radar on it, and it bounces a radar signal off the sea surface. And the amazing thing we can do is that satellite is 1,300 kilometres in space, but we can measure the distance from the satellite to the sea surface to within a centimetre. And that means we can measure sea level everywhere, because the satellite measures everywhere. And if you look at the satellite years, we get a much better fit. And you can see the red straight line they've put through this of 3.1 millimetres per year shows that sea level is now increasing to about 3 millimetres. So it seems to have accelerated. It's difficult to prove because this one is very wobbly, but it appears to be accelerating. So you can assume that back here it's mainly the result of the last ice age, and as you come here you're starting to see the global warming signal. Because it's actually more complicated, and that's global mean sea level with the seasonal cycle removed. If I put the season back in, you can see that sea level actually goes up in our summer, because the northern hemisphere has a bigger seasonal cycle than the southern hemisphere, so the oceans heat up in the summer in the northern hemisphere and expand, and then they contract, so you get this wobble on there. And there's sort of saying in sea level research, no one was ever drowned by global sea level. We don't really care about global sea level, we care about local sea level, so this is a map of what's happened locally. And you can see that it's not constant. The sea level isn't going up the same everywhere. This is to do with the heat storage of the ocean. So as you change the amount of heat in different parts of the ocean, they expand in different amounts. So you can see that in the Pacific we've got this large rise at this end and a decrease this end. Now that doesn't necessarily mean that's going to carry on for the next 100 years, because the El Nino signal in the sea level in the Pacific affects sea level a lot. So over 93 to 2011, the number of El Ninos and the number of La Ninas will affect that pattern. So that pattern is complicated, we think we understand it, but we can't really, it's difficult to predict exactly what's going to happen to the future. What is going to happen in the future? Well, yeah. This is from the last IPCC, not the next one. I couldn't manage to find the figures, the current figures, so this is slightly out of date. This is what the models show, and this is the uncertainty, and if you put an additional uncertainty, because we don't know what the ice sheet's doing in the models, get up to here. These are the observations, this is the red line here, these are the tide gauge observations, these are the satellite observations, and you can see they're at the top end of the uncertainty. It's a little bit worrying. At the time, there were some scientists who did an extrapolation, a sort of simple extrapolation, and they got really high sea level results. I don't think anyone really believes that anymore. I think we all agree that it's probably too low. So by the end of the century, I think we're looking between 50 centimetres to a metre increase in global sea level. That's bad enough. It's not 10 metres. It's slow, so you can probably adapt to it, but that doesn't mean you're going to need to pour a lot of concrete or abandon a lot of land. And particularly in countries like Bangladesh, where it's difficult for them to afford the concrete to pour, that's going to be a problem. Has anyone got any burning questions on sea level before I move on?
Any idea or knowledge about the depths to which the oceans are heated?
Okay, it's a good question. Because
Could you repeat the question?
the question was, what depth is the oceans heating to? The measurements we have certainly show that they're heating to 1,000 metres. The deep ocean, the ocean takes a long time for that to get to the bottom. It will heat all the way to the bottom. That takes time. Most of this is the expansion in the top, because the top heats more than the bottom does. So yeah, over time, the rest of the ocean will heat. Yes, but we measured it down to about 1,000 metres. We don't have many measurements below that 1,000 metres, so it's difficult to say. Yeah, sorry.
I think as you said, you think the rise in sea level over the next 100 years is 50 centimetres to metre.
50 centimetres to metre, I would estimate.
Actually, maybe what it's silly, but I mean that doesn't sound an awful lot, really. But I mean, why does that translate into big problems for say?
Well, it translates into big problems because it's not distributed evenly. So some places will get much higher sea level rise than others, and it translates into big problems in that if you have a coastal defence and you've got to put another metre of concrete on top of that, that's very expensive. So if it's not the mean sea level that's the problem, it's the extreme sea levels that are the problem to go on top of that, and you can probably add a bit extra to that, and then you've got waves sitting on top of that. So all your safety margins are being eaten away. So if you have I can't what it is, something like three quarters of the population live near the coast, something like that. It's huge numbers of people live near coasts. And if a metre doesn't sound much as it is, but if you think of that, if you were going to the seaside and we're a breakwater, and the water's often that close to that breakwater. So it's adaptable to. It's not the 5 metres if you lose Greenland, which would be very difficult to adapt to. But the Thames Barrage, for instance, they're making that bigger, and that's because of results like this. If you flood London, the cost is horrendous. So that's why it's important. It's not. I don't think rising sea level is a crisis in the sense that we have to worry about it tomorrow, unless, say, Greenland starts to slip. But it is a thing we're going to have to adapt to over the next 100 years. Okay, I need to move on. Okay, I'll quickly whiz through the overturning circulation. So this plot here shows the temperature at a point on the Earth as the difference between the average around that latitude. And you can see, and it's in our winter, so don't worry about the Southern Hemisphere, but you can see that up here, we're really toasty warm in the winter. You might not think it, but we are, compared to Alaska, which is the equivalent place. And we've both got oceans, so it isn't just having an ocean next to you, it's something else. And at school I was taught this was the Gulf Stream, but that's actually not true. It's not the Gulf Stream. It's what's called the overturning circulation. Now what happens is you get a lot of transfer of heat from the ocean to the atmosphere up here in the subarctic, because the atmosphere can get as cold as it likes, but the ocean can never get colder than about -4 because it freezes. So you can transfer as much heat out as you like, and that means you get very cold water, and you're also transferring moisture out, so you get very salty water, and cold salty water is very dense, and that sinks to the bottom. And when it sinks to the bottom, it pulls warm fresh water up through the Atlantic, and that gives us equitable winters. That's why we get quite nice winters. It's why you can plant tropical plants in Cornwall.
How's that different to the Gulf Stream? Sorry.
The Gulf Stream is a horizontal circulation.
Okay.
So the Gulf Stream whizzing around here, and it's moved further north. But this is overturning.
Yeah.
This is actually going down to 3,000 metres. So it's the overturning That's a very good question.
Yeah, thank you.
But there's an equivalent horizontal circulation in the Pacific. There's no overturning in the Pacific.
Can I just suggest that we hold the questions until
Yeah, okay.
today?
Okay.
Sorry.
Okay, so can you shut that circulation off? Well, people drill in Greenland for ice cores. I'll skip over that a little bit quickly. And this is oxygenating, it's a temperature basically in Greenland. And this is the last ice age, and we come out the last ice age and we go into what's called the Younger Dryas, and then we come out again, and then here it gets really cold for a few thousand years, 8,000 years ago. What's called the 8.2 kiloyear event. And we think that happened, there was a big glacial lake here in Canada, and the ice was melting and it broke here. And all that water, all that fresh water, just flowed out into the Atlantic and shut down circulation. And there's lots of sources for fresh water as we melt. Ice, the sea ice is melting, the ice sheet's melting, there's more rainfall because we're speeding up the hydrological cycle. And if you do shut down circulation, you can do that in a model. Here they've done it in a model, and it gets cold. But more importantly, you change the precipitation and you kill the Amazon. What you do in this model, it's only a model. So the UK has started measuring this circulation. We have a series of buoys all the way across the Atlantic. They go out every 6 months or so and get the data back and put in new buoys. And the measurements, so they don't show a great decline, which is useful because we had some previous measurements, some very episodic ones indeed. The models do show a slowing of the next century, but the collapse is probably very unlikely, but it is possible. So that's what my current research is on, trying to work out what that risk is, what that chance is. And finally, I'll just talk a little bit about ocean acidification. If you add CO2 to water, it becomes acidic. And so as we increase CO2 in the atmosphere, the seawater is going to become more acid. And that's GCSE chemistry, that's not very complicated, there's no great computer models involved in that. And the more acid the water becomes, it becomes harder to create calcium carbonate. And calcium carbonate are the shells of the creatures that live in the ocean. So these things are what are called coccolithophores, and they're absolutely tiny. You need an electron microscope to take those pictures. But they're in such numbers that you can actually see a coccolithophore bloom from space. This is from a satellite, and you can see this white milky pattern, and that's millions and millions of shells from these. They're actually dead at this point. They're the shells from these really tiny little people. But if you make the water more acid, they're going to find it very hard to generate those shells. So you're going to change the ecosystem quite seriously. And that's in the North Atlantic. If you go to the tropics, of course, coral reefs are again built out of calcium carbonate. And coral reefs actually get it both ways. They get bleaching from high temperatures, which kills the coral, and the acidification is actually going to eat it away and make it much harder for those coral polyps to actually produce the shells. Anyway, that's probably it. Do you want to take some questions now, or
We'll take questions after Elizabeth's presentation, so we can combine all the questions together.
Okay. Thank you.
Hi, hello. So as Sam said, I'm Elizabeth. I'm here to talk more, louder. I'm here today speaking on behalf of the Green Party, where we've just recently developed a completely new policy for marine and coastal issues. So why are oceans important? Well, Peter's touched a little bit on this. They cover 71% of the world's surface, but actually 98% of the habitable volume of the Earth is the ocean. Lots of people rely on them for food and livelihoods. Really important for climate. They hold 10% of the carbon of plants and soil in the terrestrial environments. And every second breath we take is thanks to the ocean. So when we're talking about, climate change, like actually looking after our oceans is as important as looking after our forests. They face multiple threats. We've already heard a little bit about climate and what ocean acidification does to habitats, and of course a lot of these threats are sort of interlinked. I'm mostly going to be talking about overfishing, but I do just want to say a little bit about pollution, particularly plastic pollution. This is a dead albatross chick that's been found, and you can see there's what looks like a lighter in there, like bottle tops. This is not uncommon, unfortunately, anymore. 44% of the species of birds in the world are known to have ingested plastic. And given that this is a really quite recent phenomenon and it hasn't been that studied yet, it's likely that that's a massive underestimate. We also have other pollution issues. Who knows what happens when fish that have ingested plastic has attracted contaminants like DDT. Who knows what happens when we then eat those fish. You also have runoff from agriculture, issues around habitat loss. So we've already talked about coral reefs and how they're suffering from ocean acidification. Coral reefs are actually the most threatened ecosystem habitat type on the planet now. But there's also seagrasses, which have declined by 29%, mangroves declined by 38%. But overfishing is arguably one of the biggest issues that's facing our oceans, and that's what I'm mostly going to be talking about. So we are overfishing our oceans. There is no doubt about that. There are just too many boats and too little fish. There's just some figures here. We take more than 800 million tonnes of fish and invertebrates from the sea every year. And scientists, the estimates do vary, but things like 70% of fish stocks now fully exploited in the European Union. It's estimated higher than that, about 85%. Bycatch is a massive issue. So every year you might have heard about the discards ban that Hugh Fearnley-Whittingstall's been campaigning for. So in the North Sea, currently 60% of the fish that we catch actually goes back overboard dead. And that can include things like cod, just because it's over quota, even though these are threatened species and things that are also commercially valuable. But then you've also got bycatch of things like cetaceans, so 300,000 rather cetaceans, including dolphins, killed every year as bycatch. That's again a really conservative estimate. And 100,000 albatrosses, 100 million sharks and rays every year killed as bycatch. And if we carry on like this, essentially, it's we're damaging the environment. We're also damaging people's livelihoods, people's sources of food. Something has to change. So this is a map from the WWF from their Living Planet report. This is the state of the oceans in 1950. So you can see sort of blue, a little bit of orange and a lot of red. So what these different areas mean, it's talking about the primary production rate. And primary production rate is just a measure of how much food there is for fish. So blue areas, it's 10% gone. The orange is 20% extracted, and the red is 30% extracted. But the main thing to know is just where the sea is red, that is where it would be considered that it's overfished. So this is the situation we had in 1950. If we flash forward to 2006, that's where we were in 2006. So you can see an awful lot of the ocean is red. And if you look all around the UK, you'll have seen in the earlier slide that it was already bad, but it is one of the most exploited parts of our ocean. And this was 6 years ago, so things have possibly got quite a lot worse since then. So this is the Alternative Rio Summit. Governments are currently gathering now in Rio to discuss what can we do about this. So what can they do? Well, to be honest, actually most of the things they need to do are things that they've already committed to doing that they just haven't done yet. So they know what they need to do, they just somehow haven't got themselves together and actually implemented things. So they committed to 10% coverage of marine protected areas by 2012. Well, we don't have that, we've missed that target by a long way, so they've now pushed it back to 2020. They've committed to eliminating illegal, unreported and unregulated fishing, which is referred to as IUU, which costs the global economy something like $23 billion a year. They said they'd eliminate that by 2004, they haven't. They said they've reduced the rate of biodiversity loss by 2010. Instead, the rate is accelerating. We need to step up to the plate and do this. We need to listen to the science, implement the quotas, reduce the amount of fishing effort, introduce sustainable gear, help like small-scale independent fishermen who know what's going on in the oceans to actually transition to a more sustainable way of doing things, and adopt an ecosystems approach that really considers the whole ecosystem and habitat rather than looking at very specific species and niche vulnerable areas. And the main thing I'm going to be talking about is the need to create networks of marine protected areas, including, and it's very important to include, some big areas where there is no extraction at all to give fish stocks a chance to recover. So marine reserves work. There's a lot of evidence now to show that marine reserves work. These figures are from a kind of meta-analysis of 200 studies across 120 marine reserves that just found massive increases in the amount of fish, the biomass, the size of the fish, and this picture here is from the Lundy no-take reserve down in the Bristol Channel, which is one of only 3 no-take zones we have in British waters. And you can see that, the lobster on the left is outside the no-take zone, and on the right is inside the no-take zone. And that's just in a few years. You can see what massive difference it makes, just not having the pressure of fishing. There's also multiple societal benefits. So if you have a marine reserve where fish are allowed to recover and habitats get back to how they were, there's a spillover. So fisheries operating outside the marine reserve actually see a net benefit, are able to catch more fish and actually turn a profit, and it creates more jobs. So that's why marine reserves are so great. Now there is a little bit of a linguistic problem, which is, when is a protected area not a protected area? So quite often governments come out with announcements and they say, we've created the world's largest marine protected area, and isn't this amazing? And recently that's what the British government did around, this is South Georgia and the South Sandwich Islands. Now that looks like quite a big area, as you can see, and in fact it is, it's over 1 million square kilometres. And they announced that they'd created the world's largest marine protected area. Brilliant, hooray. Unfortunately, actually only 2% of that area is completely off-take to fishing and extraction. That's 20,000 square kilometres. The rest of it is still industrially fished. And yes, arguably they have done some very good things to manage the fisheries down there. They have put a ban on bottom trawling, for example, which is very good, and that applies across the whole area. But that is not, I don't think, what most people would imagine you mean when you talk about a marine protected area, that there is still large-scale industrial fishing going on. I think most people would imagine it was more protected than that. And indeed, we do need more protection than that in a lot of parts of the ocean. So, although the figure for how much the ocean is covered by marine protected areas is around 2.6%, and again, the data isn't very good, and bear in mind our goal is 10% from the Convention on Biological Diversity, and actually most scientists would say we need to be looking more at 30% if we're to look at a proper recovery of the oceans. Even that 2.6% figure is not full protection. Actually, what we're really looking at is less than 0.5% of the ocean protected in fully no-take reserves. So, there is some good news. So earlier this week, you might have heard, in the run-up to Rio, the Australian government announced something big for the oceans. Really, they have taken a leadership role globally in protecting their oceans. They already had the Great Barrier Reef Marine Park, of which 33% was no-take. And earlier this week, they announced the creation of the world's largest network of MPAs, spanning an additional 2.3 million square kilometres, and that's bigger than Western Europe. I tried adding it up, it's bigger than France plus Germany plus Spain plus, huge. And that brings the total amount of some protection in their waters to 3.1 million square kilometres, of which 843,000 is no-take. And they've created the world's second largest no-take marine reserve, so a contiguous area that is all completely protected, and that's about the size of Spain in the Coral Sea. Now this was a great result. They had already put plans on the table. They had a big consultation, invited input from loads of stakeholders. 99.9% of people who replied to the consultation actually said they wanted more protection, particularly for the Coral Sea. And as a result of that, the government increased the number of reefs that they were protecting and added an additional 5 reefs on. So it does kind of show that they were prepared to listen to people, even though there was fierce opposition from the fishing industry and the oil and gas industry. There has been a little bit of criticism that maybe they could have protected more of the reefs in the Coral Sea, and maybe they were kind of avoiding some of the areas where the oil industry was interested. But I think overall, compared to what other governments are doing, this is a massive, massive step forward. So I just want to show you a map, just so you kind of get an idea of how these things work, because they're always a little bit complicated. You know, really heavily zoned areas. But this big green area up here, this is the Coral Sea. This area here is the Great Barrier Reef Marine Park. So you can see that this big area here now, which contains some of the world's most important coral reef habitats, has got a really good level of protection. So the green is no-take, high protection. The yellow is slightly less good, there's some kind of hand line and hand collecting and recreational fishing. And then the blue areas are protected from some things like bottom trawling, but not all kinds of fishing. So, how does the UK government compare? Well, that's an interesting question. So, we have 3 no-take marine reserves around UK waters, which add up to a massive 0.005% of the seas around the UK coast protected. That's truly, truly visionary from the British government, I think we can agree. The 2009 Marine and Coastal Access Act, brought in by the Labour government, introduced a framework for actually trying to improve this situation and getting more marine protection zones around the UK coast. We've spent years on a massive consultation process. It's cost millions of pounds. And in the end, the outcome we have is this map here, which shows you there's 127 sites that have been proposed. These are the little hatched out areas. Unfortunately, what you can't see is the 60-odd reference areas, and that would be the no-take element. Because they're so small, they're incredibly small, really nothing at all to get excited about. All of these hatched out areas that are suggested are in fact multi-use to some extent. And even this is not necessarily going to happen. After this big consultation, the government is now saying that there isn't actually enough scientific evidence that, you know, having marine protection is good. So we're possibly looking at maybe about 20 of these sites being designated next year, which was the time frame by which the government had committed themselves to, and then others designated after that. But it's really complete lack of ambition and failing to address the problem. There is another side to the UK story, which is this. So many people might not know necessarily that the UK still has 14 territories overseas. Most people know about the Falklands, it's in the news a lot at the moment. But all these areas here where you can see shaded blue, that is ocean that technically the UK still has jurisdiction over. And this means that the UK actually has the 5th largest marine area in the world. And because it's within overseas territories, it's actually arranged over kind of a degree of latitude types, different habitats. Thanks to our overseas territories, Britain is responsible for the world's largest coral atoll and the cleanest seawater, which is in the Chagos archipelago here. We're responsible for arguably one of the most important marine ecosystems in the world. In South Georgia, it's more biodiverse than the Galapagos in terms of marine species, over 100 million seabirds, whales, seals. The largest nesting point for green turtles, one of the largest in the Atlantic in Ascension Island, and completely pristine coral atolls down in Pitcairn, and the Sargasso Sea up in Bermuda as well. So really interesting range of habitat types, and if the UK wants to, working with local populations where they exist in these territories, we can actually do something really amazing for marine conservation. We have an opportunity here that other countries don't have. So this is again just saying some of the things I've already mentioned. The UK did, in 2010, create the world's largest marine reserve in the Chagos archipelago, 640,000 square kilometres, and that's larger than France. It remains the world's largest, and that's kind of just an example of the kind of thing that the UK could do. Most UK overseas territories currently have 0% protection, not even really MPAs, which only offer kind of half protection. But so far, the UK despite the dismal performance around our own mainland, has designated about 9.5% of its total waters as no-take areas, which is an awful lot better than most other governments have done. But as I've explained, we kind of have an opportunity to do a lot more that a lot of other governments don't have. So, there's a lot of NGOs calling for more marine reserves, and actually on today, at the Rio conference, actually in Rio, the Marine Reserves Coalition, which is these NGOs here, are going to be presenting their manifesto of marine reserves and calling on global governments to designate up to at least 30% of their oceans as marine reserves. We need fully protected areas that are well managed, and some areas like South Georgia and the South Sandwich Islands, we would argue, should be protected in their entirety. The UK does not have to be running fisheries operations down there. It doesn't really earn us any money. In fact, for a few years it's been losing money. We should be protecting areas like that really are kind of, jewels in the world's crown. I mean, they're really important. This is something actually that was called for by the Royal Commission on Environmental Pollution back in 2004. They called for this. The Labour government didn't really pay much attention to them, and then the coalition government, when they came in, shut the commission down. So that kind of shows you what they thought of that recommendation. But that was a really thorough assessment of all the evidence, and the figure of 30% is what they came up with. And we're a long way from that at the moment. So what does the Green Party want to see? So unsurprisingly, we do support 30% marine reserves. We're the only party in the UK that actually has a comprehensive marine policy. I had a little look to try and find some of the others' policies, and they kind of say good things about Hughes fish fight and stuff. But the Conservatives and the Lib Dems aren't doing very well with the conservation thing around the UK coast, and I couldn't really find much about their marine policies, to be honest. And I don't know of anything that they're saying. So we're the only ones that actually have a comprehensive policy. It covers a lot more things than the things that I've outlined today. We also have things about exciting topics like aggregate marine dredging, if anyone's interested in that. Things to do with shipping, offshore energy, that sort of thing. But essentially, we would like to see scientifically determined quotas. We would like to see the science listened to. We would like to see a precautionary approach to our oceans, managed with an ecosystems approach, and actually also incentivising the fishermen who are doing well, because there's a lot of small-scale communities around British coasts who really are fighting very hard for their livelihoods, and they know what's going on in the ocean. You might have seen Greenpeace are running a really good campaign at the moment called Be a Fisherman's Friend, and that's all about how do we shift the balance. At the moment, 90% of Britain's fishing quota goes to these big, what are called producer organisations, who are the kind of represent the big industrial fishers, and only 3% of the quota goes to the small-scale independent fishers, which usually are the ones operating more sustainably anyway. So we need radical change, and I'd like to say thank you, and that's some nice goatfish, and here's some links for some of the things I spoke about.
Okay, brilliant. We've now got plenty of time for questions, about half an hour, so all the questions have been storing up. Because Peter, you could both come up to the front, and then we'll take questions and direct them to either one of you. Yes?
It's about fishing. I'm old enough to remember the Cod Wars.
Yeah.
And Iceland decided that it wanted to protect its fishing rights.
Yeah.
We needed a navy, and they was actually excluding our fishing fleet to make sure that they couldn't do it.
Right.
If you're putting up protection areas, you need them policed.
Yes, you do. Yes.
How do you get international cooperation when you need some large country, China, who decides to go and fish, and then you've got a real problem in terms of the negotiation table.
Yeah.
That's great. Sounds great.
Yeah.
If you're going to put an area down, you've got to be able to police it at the same time.
So your question was, I guess, how do we police? Is that right?
Well, my question is, given the real politics that's out there,
Yeah.
what practical steps can you say? You can say, the UK government can say, hey, we've got the Sandwich Islands, it's all protected.
Yeah.
We haven't got a navy that goes down there to protect it.
It's a really important issue, actually, and it's something, I mean, the vast majority of the UK's overseas territories are not protected at all. So, there's some places like around Ascension, they've just started letting fishing licenses. They've got no enforcement, they've got no monitoring. They don't know what those fishing boats are doing out there at all. They have no idea if, one boat buys a license and then 10 other boats from that same country come along for the ride. They have no idea. And this is something where, bizarrely, we're prepared to spend money policing a lot of other issues. We don't seem to be prepared to spend money policing our oceans. We don't seem to regard illegal fishing as illegal in the same way that we regard other things as illegal. And that's definitely something where we need to redirect funds. I mean, speaking from a Green Party perspective, there's a lot of things that I think we would stop the military from doing and put money into things like that. And that is one of the big issues that's going to come up at Rio, I think, as the governments are meeting, because there really isn't, the high seas, at least within the territorial waters of each individual nation, if they have the willingness, they can put money into making sure the Navy goes out to protect it. But on the high seas, there really is nothing. It's kind of like the Wild West out there. And there needs to be some kind of international agreement for how we go about protecting the high seas. But yeah, that's a massive issue and totally neglected. It just needs funding, basically. It just needs someone to say to the Navy, you're doing this now.
Yeah, right in front.
Yeah, well, I've got questions to both of you, actually. Elizabeth, first of all, are the large factory ships able to fish? Are they seen to be going into these reserves? And could one protect it by satellite imaging?
Satellite imaging is kind of very interesting and new technology, and you definitely can see what's going on in areas. The problem is kind of necessarily having the legal framework to back it up. So there's a lot of instances where satellite images have detected boats, fishing boats, moving in a fishing pattern, hanging around in an area, doing what they would do if they were fishing. But nobody is willing to try and prosecute on the basis of that information, because it's not clear that just being seen to be operating in a fishing pattern in a place where you're not supposed to be fishing is sufficient evidence to say that they were fishing. So what we need is kind of actually a change in sort of the legal setup. I think when a marine reserve is established, it should be made clear. Like some places in Florida, for example, they have a rule that if you're found transiting through the marine reserve with fish on your boat, then that's illegal. You are assumed to have got that fish from within the reserve. Even if you're not found, kind of nets, lines in the water. And I think we need to have something that says, if satellites detect you operating in a fishing pattern, then, you were fishing. These, big industrial boats do go and fish in no-take reserves, definitely. There's just not enough enforcement. I mean, there are some fishermen that will respect the law, so it's still worth having a marine reserve, even if you don't have adequate enforcement, just because some will respect it, but a lot won't, and that's definitely a big problem.
Yeah, and the question for Peter about the Atlantic drift, the warm water that gets to our shores.
Yes.
Does it vary in widths and exactly where it goes past the US? Let's be hectares, I think.
Yeah. So you've got the Gulf. This is where the Gulf Stream does come into this thing. So pretend this is the map of the North Atlantic. So you've got the US and Canada over here, and you've got UK sitting up here. So the Gulf Stream comes up here, which is warm current, and that's actually quite narrow. As it separates from the US coast, it becomes much more diffuse. One part comes across the Azores, and the other part comes up here, and it becomes much wider and diffuse. So it stops being a narrow current, it's a river in the sea, and becomes a much wider thing. So the heat is actually being brought generally up. And the reason we get warm is the fact that then heats the atmosphere. So you just can't think of the ocean in isolation. So if you've got hot water, you've got hot, warmer atmosphere, and that's the thing that actually spreads it around a bit. So the system is very coupled.
So it's the surface water which
It's the surface water.
counts
Yes,
here.
it's the surface water that's warm, and underneath the Gulf Stream there's another current.
What subjects are we talking about there?
Well, the surface, the top 200 metres. Okay, there's a little bit of oceanography. If you take a slice through the ocean, the top bit of the ocean is actually mixed because the wind blows and that puts a lot of mixing, a lot of turbulence in. And in the winter that can mix out a couple of millimetres. In the summer, when you heat it, it does the opposite of mixing. You heat it and that becomes warm and less dense and sort of puts a layer on the top. So that mixed layer may be only a few tens of metres. So in the summer it's less mixed than in the winter. So that the warm water tends to stay on the surface and the cold water mixes down. So that increases the effect of the sort of warmness. Makes sense.
This is totally independent of the North Atlantic drift.
Yes, that's just what happens. Any body of water will happen, and a winter storm will mix it down, and a summer heating will just heat it up. And then you've got the sideways movement, which is the currents, and so it comes up a very narrow current here. It's actually coming back on the eastern side, but the warm water is coming up, and it spreads out as it comes across the northern Atlantic. By the time it gets to us, it's really wide, diffuse, and you can't actually find a current. It's really just the water moving northwards. Is that?
Yeah.
Okay.
I read that Franklin started putting buckets down to measure the heat of water.
Yes.
But,
that's when.
And that he found a distinct separation between the
yes. So off
Gulf
the US,
Stream and the water.
there is actually a very fixed current. If you look at a satellite image, an infrared image, you see the temperature, you can actually see there's a very narrow thing. And you get eddies spun off that, which are like depressions in the atmosphere, but they're much smaller. So there's lots going on down there, but you do get this sort of hot river off the US coast. You get the same thing off the Japanese coast.
Okay.
The Kurishio.
Great, we've got quite a few questions, so I'll just point out the order. So it's you first, sir, and then you at the end, and then we'll go to you there, and then you fourth, and then I've got a question as well.
In terms of personal action, what, if any, fish may we eat?
Well, I'm not personally an expert on this because I'm actually a vegetarian and I don't eat any fish.
You waste time.
But I would recommend very much that you look on the Marine Conservation Society's website. They have a downloadable book. That's mcsuk.org, I think. They have a downloadable book. Also, Selfridges department store here in London. They've actually done a really great campaign in the last few years, something called Project Ocean, where they have completely overhauled the fish that they serve in their food hall. Everything that they serve now in their food hall, even at the concessions, so in places like Pret a Manger and Yo Sushi, they've got rid of all of the red listed fish from the MCS fish guide, and they've also produced their own little pocket guides that you can have. So there's one, Selfridges do one, the Marine Conservation Society do one, there's also one done by the Marine Stewardship Council, but I would say yes, the Marine Conservation Society guide is the place to look. But sardines are good. You can eat sardines.
Thank you.
Yeah, I can't, maybe I'm not the only deaf person here, but it would help very much if questions are repeated.
Sure.
People at the front,
Okay.
if that's possible.
That's fine.
Now my question.
As another deaf person, may I support that?
That's right. I can do that for you. That's fine.
Peter, almost at the beginning of his presentation, mentioned not only acidification of the ocean, pH change, but also this is the one element of climate change which the denialists or dissenters cannot deny. Therefore, at Southampton University, there must be people who are not only witnessing what's going wrong, but must be thinking about what must be done to correct things. How do you correct acidification? Therefore, surely that means not only cutting down on fossil fuel emissions to the extent that emissions go down, but also the atmospheric concentrations themselves come down, so that we're reversing the process whereby excess carbon dioxide no longer goes through the surface of the ocean, down into the ocean and changes the carbonic chemistry, but the reverse happens. Is anybody in Southampton looking at this?
So just to repeat the question, how do we reverse acidification?
Okay. I don't think anyone, particularly in Southampton, there are people around the world who are looking at how you can remove CO2 from the atmosphere. That's what you have to do. It's not, yes, we have to stop putting it out, but the fact is it's higher than it was. It will acidify the ocean. So there are There was a session on geoengineering at the same time as we were here, so you can't have gone to both of them. This is a shame. So I've been going into that. But geoengineering all the way from planting trees, which will take out CO2, to people have talked about using I've got this magnesium. No, my chemicals, my chemistry right. Manganese oxide, which you could turn into manganese. I think it's manganese. No, I got that wrong. It's not manganese. Anyway, there's a mineral that is very plentiful. It's an oxide. You can turn it into a carbonate, and that would take out CO2. Unfortunately, at the moment, that takes more energy than it removes, but chemists are working on that. If you do nothing, if we stopped emitting CO2 and we did nothing, eventually it would go back to where it was before. Because the natural ecosystem will stop up the CO2 and will get back into balance. Unless we've pushed it over some sort of tipping point. There's little evidence we've done that yet. So if you actually stop, it would eventually go back to 280. 280 is about the pre-industrial level. If things happen very slowly, ecosystems can cope because things can evolve. They can't do, the problem with what we're doing now compared to say coming out of an ice age, it's happening very, very quickly. Things can't evolve, they can't actually change in time. So yes, we probably should be looking to ways to actually remove carbon dioxide from the atmosphere. There are people working on that. The trouble with all this geoengineering is the law of unintended consequences. When you do something you don't know, you're not going to do something else.
Repeat what you said.
So the law of unintended consequences, when you tamper with a system as complex as the Earth system, you push one bit and some other bit pops up and you don't actually know what's happening. That's what we've done by putting out CO2. Everyone thought that wasn't a problem. It wasn't, people didn't do it in a deliberately evil way. It just was a consequence of burning coal that didn't think anything of, and in fact it's turned out to be a disastrous thing to be done. So we have to be very careful about what we do.
Okay. Thank you. Over to you.
Okay, in addition to what you said, even the best IPCC scenario puts carbon at 600, almost to 600 ppm, if I'm not mistaken.
I think they actually...
So the question there was around the concentration of CO2 in the atmosphere.
I'm just saying, do you put all your trust in bioengineering? I mean, even if we start planting trees in the Amazon and how Brazil wants their project to go well, is that enough?
No, I'm not
reducing.
Okay, this is my
So what is enough?
Yeah, this is my personal opinion about geoengineering. The people who do geoengineering talk about it as a insurance policy. You hold it in your back pocket if you use it, if you can't do anything else.
But is it tangible? Because at the moment it's all about projects. Nothing really.
There isn't a workable scheme at the moment. The one that they talk about in the ocean is to put iron into the ocean, and they have demonstrated if you put iron into the ocean, iron is a nutrient that's lacking in the ocean generally. So if you scatter iron around, you can generate a big bloom. Yeah, and there are natural sources of iron in the ocean. You can see you get more phytoplankton produced, and you should pull down carbon dioxide. So in theory, you might, if you just spread lots of iron around, you could suck the carbon dioxide. But if you do that continually, you change the ocean ecosystem, and it may go into a state where it doesn't actually absorb any more CO2. It just gets to a different set, which eats the iron and doesn't actually. You don't get that boost that you get from putting iron in. So I'm very sceptical about these schemes.
I think they did a few trials.
Yeah, there have been trials. There have been trials.
Weren't that spectacular?
It depends where you do it. There's an island in the South Atlantic, Kerguelen Island in the South Atlantic, which is a natural source of iron. And you can actually see that as the Antarctic circumpolar current goes past, you get this little green spot. And that's because it's going past Kerguelen. But there it's you've continually got new plants coming past because the thing's being zipped past by the current. So I'm sceptic about putting iron into the ocean, but I know some people think this may be a solution to what we want to do, but I worry about it.
Can I just add something? Something that is quite cool is it has been posited that, and this is a link between why the biodiversity crisis and the climate crisis are intertwined, posited that actually if we hadn't killed so many whales, we wouldn't have such a problem with iron depletion, because actually whales excrete quite a lot of iron. So actually the oceans would be more iron rich if we hadn't killed all the whales. So it's just a little link.
Sorry.
Two relatively short, one for Elizabeth.
You go for it.
Elizabeth, you were talking about the Chagos archipelago, and I just wanted to refer a little bit back to what the lady brought up here. The Chagos archipelago, I mean, the British government actually kicked out the native population back in the 60s, I believe.
Yeah, late 60s.
And my question relates to that.
Yeah.
Diego Garcia is, I think, the largest military base, off-land military base for the Americans. We lease it to the Americans.
Yeah.
So in that sense, it's quite an easy area to protect, because you have a military exclusion zone plus a lot of shipping. My question is, the Chagos people won the right to return to their islands, I think 2 years ago. Will they be allowed to?
Well, okay.
Oh, they won the right to. I don't think they have actually been allowed to return, but I'm not sure. Will they actually be able to sustainably fish in the Chagos archipelago?
Okay. I'm glad that you've asked this actually, because I didn't want to bring up the whole Chagos backstory in my talk, because that's not what we're here to talk about the ocean. And the reason I didn't bring it up in my talk is because to do full justice to the history of the Chagos archipelago, I think I would have had to add on about an extra half an hour. It is, this is kind of real politic in action here. The Chagosian people have not won the right to return. In 2000, there was a local population on the Chagos archipelago. The Americans wanted to set up a military base. The British government in the late 60s decided that they wanted to help the Americans, and one of the conditions for doing that was to remove the local population. So that's what we did. We removed them from Mauritius. Since then, they now have British passports, so about half the current population is now living in Britain, half in Mauritius. It's fair to say that both Britain and Mauritius has treated these people pretty shoddily, basically, and that certain groups of these people have been campaigning for the right to return ever since. They were granted the right to return in 2000 by Robin Cook. Then when Jack Straw took over, he invoked the, basically he got the Queen to step in and say no, they couldn't go back. So they are actually currently still fighting for the right to return, and that's due to come up at the European Court of Human Rights at some point, but it's been due to come up at some point for about the last 3 years. So, who knows when that's actually going to happen. If the Chagosian people are granted the right to return, and it's personally, I'm not convinced that that's ever going to happen, although I think that they should be granted the right to return, obviously. If they are, then it's unclear as to how many would actually go back now. These are low-lying islands. When they lived there before, they were working on copra plantations. It was a very subsistence, it was very kind of simple lifestyle. They had to have a lot of things flown in anyway because certain things wouldn't grow there. It's unclear how many people would want to return, given that a lot of them are now used to a kind of more modern life in Britain, where they've got, Tesco and Sky TV and stuff. But if they did go back, the British government has said that the creation of the marine reserve was without prejudice to any kind of future changes that might happen in the archipelago. So that means that anything about the rules for the marine reserve could be changed and could be overturned. I mean, to be honest, I don't think you could very well say to a group of people, yes, you can go back there and live, but by the way, you can't do any fishing. That would just be ridiculous. And I think that pretty much all of the conservation groups who backed the creation of the marine reserve, if the Chagosians went back, we would be obviously in favour of them being able to support themselves, and we want to work with them to kind of ensure that it was, sort of as sustainable as they wanted it to be.
They wouldn't have the right to, for example, what's happening in a lot of the least developed countries, the selling of their fishing rights to commercial fishing fleets.
Right.
They wouldn't have that right.
I think this is all kind of, speculative in the future, and I don't know. I mean, if the Chagosians were granted the right to go back, it would completely change, be other things that would change as well. I mean, the military base on Diego Garcia, the Americans have made very clear they don't want any people in the archipelago. This is one of their most important strategic bases. Personally, I'd rather that wasn't there either. But this is it's a complicated situation, and I think if they went back, you'd have to hope that they were going back under a situation in which they have the right to self-determination and they had the right, it was kind of acknowledged that this was their land and they could choose to do with it what they wanted. And as conservationists, we have to hope that what they wanted to do with it was protected, but that would be their decision.
Sorry.
Yeah, the second question. Second question. Yeah.
It's actually connected with something that Elizabeth brought up. I wanted to ask Peter about this. The issue of blue carbon. With seagrasses and mangrove sequestration of carbon. With sea acidification, is there actually a connection between the destruction and the gradual destruction of seagrass areas? Is there actually a connection between that and sea acidification? Obviously with shipping, dredging, the construction of coastal defences, that's severely damaging seagrasses and mangroves. But I'm just wondering, is there a connection between increased sea acidification?
Okay, I'll preface this by saying I'm not a chemist. I'm not an ocean chemist. I'm a mathematician in physics first. Not that I know of. I think the big threat to mangroves and coastal wetlands is more sea level rise. Which they're intertidal. So if you move everything up by a metre, then you've moved inland a long way, and they have to. It's this thing that trees take a long time to grow, and they can't rapidly move inland with the intertidal stuff. So I think that sea level rise is more of a threat and coastal development to mangroves and such like. But mangroves are they're great coastal defences actually.
Yes.
If you want to defend a tropical coast, a mangrove swamp will be a lot better than a massive concrete. Yeah.
It just worries me that blue carbon does not seem to be. I mean, we have the year of blue carbon. I think it's 2 years. Yeah, exactly. But I believe it's 55% of the carbon sequestered in the world is in the oceans, and it's sequestered for thousands of years, not hundreds of years as in forest and land-based, soil sequestration as well. But yeah, I mean, it's completely below the radar. Is this going to be brought up at the Rio conference by all of these groups that are working on ocean preservation?
I think so, but I don't think it's one of the major topics under discussion, unfortunately. I mean, I think even, they have their kind of headline themes, of which oceans is one.
Yeah, I haven't seen
but I think, to be honest, even oceans is going to kind of be under the radar of things like the green economy and kind of food security and water security, things like that. I mean, I'm sure that things like blue carbon and governments seem very keen to marketise pretty much any natural resource you can think of. So there might be a lot of talk on those lines. It's worth saying actually that one of the projects I know a little bit about to protect the Sargasso Sea, part of the threat there was that the sargassum, which is kind of these floating kind of seaweed mats that form this unique ecosystem in the Sargasso Sea. There has been some advances from biofuel companies to turn this into green energy by harvesting the sargassum. So and that would be a big threat to biodiversity, and also it would be kind of we're just transferring the
Shifting from one to another.
Yeah.
I've got a question. I said we've got a couple more. I just had one to add for both of you as well. What do you see the role of the International Maritime Organization as being, A, in advancing the science on oceans, and B, in protecting marine areas?
As far as I know, the IMO is mainly concerned with shipping. There are other organisations to do with scientific research. One of the ones that we talked about carbon sequestration using iron. And there's been a lot of the London Dumping Convention, which is about dumping stuff at sea, which stop the dumping of radioactive waste to the sea a few years ago when they changed it. And they used that to stop actually research into iron sequestration. So
this stops research?
Yes.
Okay.
Because to actually put the iron out is deliberately putting the pollutants into the ocean. So research there is very controversial, and trying to get exemptions through the London Dumping Convention to do that research has proved to be quite difficult and a very controversial topic. I say geoengineering is very controversial because it's sort of a moral hazard that if you can just sweep the carbon under the carpet, you have to worry about mitigating and all the other things I think everyone here approves of. So there's a lot of political controversy about those things. So yeah, these international conventions are important. They don't provide any funding, which is for research. Unfortunately, it all goes with funding.
Yeah, I'm probably going to say, I mean, the IMO is mostly to do with shipping. I know that there are people I know of who are working a lot on IUU, illegal, unreported and unregulated fishing, and are in conversation with people at the IMO about kind of creative ways of dealing with these problems. It's not something I know a huge amount about, but I think kind of in terms of enforcing the oceans, we need every kind of body on board in terms of kind of getting the result that we need.
Right. One thing you could do is all aircraft have a transponder, so you can find where aircraft are from space, from satellites. Ships don't have that. So if you actually put a transponder on all the ships, so you could actually know where they were, you would know which one was in a marine protected area, and you could send a fisheries protection vessel out there to ask what it was doing there. Because if it sits there for several days, it's either got a broken engine and wants rescuing, or...
What about if it switches its transponder off?
Sorry?
What about if it switches its transponder off?
Well, you know it switched its transponder off. You could ask questions as well.
Yeah, I mean, some vessels do have these things, but at the moment it's all kind of really quite voluntary, and most people don't, and it's all a bit a sham.
Okay, I've got quite a few, so we'll take two more. First use, and then you.
About the IMO, I happen to be researching them at the moment, and they have come forward with proposals which are going to be imposed on international shipping to reduce carbon dioxide and sulfur and nitrogen emissions from their shipping. But they're very, very loose. They're only asking for 10% per ship over the next few years, and they won't become compulsory till the mid-1920s. But at least they are trying. So maybe some advance there, but that means they produce slightly less carbon dioxide. But at the moment, shipping produces at least 1 billion tons of carbon dioxide per year on its own, together with lots of sulfur and nitrogen emissions, which are so severe that in many places, for example, around Scandinavia and California, such ships are not allowed to have their engines going in port because of the deaths which they cause to the local population. Just a bit of info, you probably knew that anyway. Could I ask a question? Is that all right? You probably both speakers, Elizabeth and Peter, know about the United Nations Law of the Sea, which came in 1980-1982, after a lot of difficult negotiations, which nearly everybody signed up to, apart from our dear friend the United States. It was based mainly on delineation of sea areas and the rights to exploitation, etc. Do either speakers see a future for a new law of the sea, which could include marine biology, on the themes which they've been talking about this morning?
Yeah, I mean, again, this isn't something that I know a huge amount about. Sorry, should I just repeat the question? It's about the law of the sea, and is there a place for kind of incorporating more sort of issues around marine biology within it? I think it's quite important that the US didn't sign up to it, and I know that there's some kind of negotiations going on at the moment for marine reserves on the high seas, and the US is kind of being quite, they're not being very helpful. And I don't personally know that much about the law of the sea, but I do know that a lot of people who I work with think it's very unsatisfactory. And yeah, I definitely think, I mean, this is one of the things that they will be speaking about in Rio at the moment, is just a better governance model for the oceans and a better legal framework for the oceans, and how do we tie in all of these things that we need to do around kind of preservation of biodiversity and fish stocks, and actually kind of have some regulation going on out there, because at the moment, there really isn't anything, and the law of the sea doesn't seem to be adequate to kind of protect things like we need to do.
Yeah, I think that the issue is, I mean, most debates on the law of the sea are about countries seizing seabed or staking claims to seabed, and that's been happening in the Arctic, where as the sea ice melts, everyone wants the oil. But in terms of fisheries, I think the interesting thing is the bit that no one has claimed and no one can claim, and how you regulate that, how you regulate fishing outside that. I don't know if anyone here has ever eaten orange roughy, which is a New Zealand fish. It used to be quite popular in New Zealand. I think people eat it anymore because it is so endangered. And these things grow to, I think they live about 80 years. So they grow very old, and they don't actually reproduce until they're 20, 30. So, and they live at the same depth. They're a bottom fish, so that they live around seamounts in the South Pacific, on around the coast of New Zealand. Now most of those seamounts don't touch the surface, so they're about 1,000 metres down on these seamounts. And if you could get a map of where these seamounts are, and there was no, and you weren't in anyone's territorial waters, you can just go and hoover them up. And they were worth a lot of money at the time. I think people stopped eating them. It's unethical. And I know people who were producing bottom topography maps who would not publish where the seamounts were because they did not want the orange roughy to go extinct. And how you regulate and police the deep sea, which isn't in anyone's area. Elizabeth put up the nice little maps with the circles around the islands, but that's the 300-mile limit. And the bits outside there is this nebulous UN body that regulates the deep sea, but they really aren't. They don't have the authority to create marine protected areas, and they certainly don't have the authority to send out navies to stop people doing stuff there. So there is a problem there. Now a lot of that's so deep, there probably aren't a lot of fish out there, but squid fisheries, fisheries for pelagic fish, they don't have boundaries. These things don't necessarily live near land. So yeah, it's a big problem. And it probably does, and it's a political problem, it just needs to be solved.
My question is, in mainstream press, I noticed that Met Office just made some simple remarks saying that a few months back that the reason why climate models had overestimated temperature increase was because of the impacts of the oceans. And if I've got that correct, why is it that we don't really understand? Why would the oceans not be completely in the climate models at this stage?
I think what the question is about is that if you look at the recent temperature rise, the last 10 years temperature hasn't really risen as much as everyone expected it to. And I don't think anyone fully understands why that is, except we do know that the oceans have been absorbing more heat over that period. So you know where the heat's gone, it's not that the amount of heat wasn't going up, it's that the temperature hasn't gone up because that's gone into the water rather than and the relationship between the atmosphere and the ocean, I say, is a complex one that isn't fully understood. There are things like El Nino, which is this big thing in the Pacific, that you get a wave travels across the Pacific and it actually kills the fishery off South America, which is why it's called El Nino, because it happens at Christmas. And when you get an El Nino year, there are no anchovies and sardines off South America. Because you get warm water there and you get cold water at the other side, and then La Nina you get the opposite, and that pulls a lot of heat down. So you really have to think of the atmosphere and the ocean as the same system. You don't have weather forecasting because the ocean has a longer time scale, so that they can get away with it there. But if you want to forecast a few years ahead, 10 years ahead, you have to get that ocean right. And we have very few measurements in the ocean. It's getting better, but we have very few measurements, and in the deep ocean we have virtually no measurements. So just getting that right is just hard. And that seems to be what happened. What measurements we've got show that there was an increase in heat in the ocean. That means the atmosphere wasn't heating as fast as you would have expected if there wasn't an ocean there. So the ocean just slows everything down as it absorbs the heat. And that's what seems to have happened. It'll probably come back again. The ocean actually might give back that heat. We might actually get, it's going up, it stops, it might actually shoot up again. So that's what we think happened. It's not global warming stopping.
Yeah, no,
not.
I do.
Slowly.
Yeah.
Okay. That's it. It's now past 7:45. Let's end the session. But thank you very much, and thank you again to both of our speakers.